In section 11.3, we're going to go through and talk about geometric sequences and series. A geometric sequence, remember, is where you're multiplying the previous number by the same value each time. Maybe you're multiplying by 3 each time, or maybe you're multiplying by a half each time. That is a geometric sequence. The general equation for a geometric sequence is a sub n equals a sub 1 r to the n minus 1 power, where a sub n is the nth term of the sequence, a sub 1 is your first term of the sequence, r equals that common ratio which you're multiplying by each time, and then n being the number of terms in the sequence. So let's go through and look at a problem where we're going to use this formula. Find a sub n if the first term is negative 3, the common ratio is negative 2, and n equals 6. So let's start out with my general formula. A sub n equals a sub 1 r to the n minus 1 power. So writing the equation, a sub n equals, well, the first term is negative 3. R, which is your common ratio, is negative 2, raised to the n, which is 6 minus 1. So if I'm going through and evaluating to find a sub n is going to equal negative 3 times negative 2 to the 5th power. Well, negative 2 to the 5th power is negative 2 times negative 2 times negative 2 times negative 2 times negative 2. That'll be negative 32. Okay, and then negative 3 times negative 32, a sub n should equal 96. Okay, so as I go through here, the sixth term of the sequence should be 96 is what we're saying. Let me show you how this actually works. Okay, so this problem said that I started with the first term, which was negative 3. The common ratio is negative 2, so that means the second term would have been 6, negative 12. I'm multiplying by negative 2 each time. 24, negative 48, and then 96. The sixth term of this sequence is 96, and that's what we came up with here. Okay? So again, we want to be able to go through and do maybe the 50th term or the 200th term of the sequence. Certainly we don't want to write all those out. That's why we need a formula that will work for geometric series or geometric sequences. Let's try example 2. Find the equation for the nth term of this sequence. So again, a sub n equals a sub 1 r to the n minus 1 power. So I'm writing the equation for the nth term. A sub 1 is 5. The common ratio, what am I multiplying by each time? That's going to be 2 to the n minus 1 power. We can always make sure this works by testing it on one of the numbers in the sequence. So let's try the fourth number. So that would mean a sub 4 is going to equal 5 times 2 to the 4 minus 1 power. So 2 cubed is 8. 8 times 5 does equal 40. The fourth term of the sequence should be 40, and it is. Example 3 says find the equation for the nth term of the sequence if a sub 5 equals 4 and r equals 3. So this one will be a little more challenging. Let's go through and write our equation. A sub n equals a sub 1 r to the n minus 1 power. So here I'm finding a sub 5, and I know a sub 5 is 4, equals a sub 1, which is what I want to try to find. And then we have r, the common ratio is 3 to the n minus 1 power. Well, the n value in this case was the 5th term. So that's raised to the 5 minus 1 power. So 4 equals a sub 1, 3 to the 4th power. 3 to the 4th power would be 81. So if I divide both sides by 81, the first term of this sequence is going to be 4 over 81. Okay. So now I'm going to use that to go through and write an equation for the nth term. So a sub n equals the first term, 4 over 81, times r, which is 3, to the n minus 1 power. There's your general equation for the situation in example 3. Now, how do I do the geometric means of the sequence? It's very important on the test that you realize if you're finding arithmetic means or geometric means. Geometric means that I'm multiplying the first term by the same value or the previous term by the same value each time, where the first term is 25 and the last term would be 32 over 125. So what we want to do is we want to go through and we want to use our formula again. Our formula is a sub n equals a sub 1 r to the n minus 1 power. Okay, and what we're after here this time is the r, that common ratio, because that'll tell me what I need to multiply the previous number by each time. A sub n, 32 over 125. That's the last number of the sequence. A sub 1 was 25, the first number. R to the n, 1, 2, 3, 4, 5, 6 terms in the sequence, so 6 minus 1 as the exponent. So I'm going to start out by multiplying both sides by 1/25. That'll isolate my r value. So multiplying by 1/25, this would be r to the 5th equals 32 divided by 125 times 25, 1325. Now, how do I find r? Well, you're going to have to take the 5th root of both sides. So the 5th root of 32 is going to be 2, and the 5th root of 3,125. I'd take 3,125 raised to the 1/5 power. That would be the 5th root, and that would give me a 5. So there is your r value. So if I multiply 25 by 2/5, that should give me the next number in the sequence, which is going to be 10. That'd be 50 divided by 5, which is 10. 10 times 2/5 would be 20 over 5, or 4. 4 times 2/5, that's going to be 8 over 5. And 8/5 times 2/5 would be 16 over 25. And then I'll multiply by 2/5 again, and that should give me my 6th number in the sequence. Multiplying by 2/5 again, that would be 32 over 125. So those are evenly spaced. There's my 4 geometric means for this sequence. Okay. Here's a story problem dealing with geometric sequences. Every year they have a snow sculpting contest down at Sinisippi Park. And here it says ice sculpture, or Sinisippi Park has ice sculptures every winter. If 1 ton of ice, of an ice sculpture, loses 1/5 of its weight per hour, how much does it weigh after 5 hours? So what we want to do is we want to write a sequence for this case. 1 ton is 2,000 pounds. So if I start with 2,000 pounds, how many pounds will I have after 1 hour? Well, it loses 1/5, so that means that that would be 4/5 of the original amount that remains. So if I multiply 4/5, that's going to be my R value, my common ratio. So 4/5 times 2,000, that would give me 1,600. So that's after 1 hour. Multiply by 4/5 again, 4/5 times 1600 this time, 1280. That's after 2 hours. After 3 hours, multiply by 4/5 again, 1024. Okay. And then multiply by 4/5 again, 819.2. So we started, 1600 was after 1 hour, 1282 hours, 1024 pounds was after 3 hours, 819.2 pounds was after 4 hours, and then after 5 hours we'll multiply by 4/5 again, 655.36. Move our picture out of the way so you can see it a little bit better here. So in this case, after 5 hours, the sculpture will weigh 655.36 pounds. Okay, so there is a story problem that would go along with a geometric sequence. Next thing we're going to talk about here are geometric series. There are two formulas with geometric series. One is when you're given the n value, and the other one's when you're given a sub n. Okay, so it all depends on if you're given a sub n or not. So these are the two formulas. If you're given a sub 1 and n, but not a sub n, you'll use s sub n, which is the sum, is the first term minus the first term times the common ratio raised to the nth power, which is the number of terms, divided by 1 minus r. Okay, the only difference in the formula in the second case is you have an a sub n, and we're not raising r to the nth power. So s sub n in the second formula equals a sub 1 minus a sub n times r, which is your common difference, divided by 1 minus r. Both cases, r cannot equal 1 because it makes the denominator 0, and that's where the number would be undefined. So let's go through and take a look at how to do the sum of a geometric series. Okay, this time I'm given a sub 1, r, and n. So that means that I want to use the first formula, which is s sub n equals a sub 1 minus a sub 1 r to the n divided by 1 minus r. Okay. Now we're just going to plug in and evaluate. This one gets a little ugly with the fractions, but we're still able to do it. The sum of the geometric series would be a sub 1, which is 4, minus a sub 1, which is 4 again, r, which is negative 1/2, to the n power, which is 8. All divided by 1 minus the r value, which was negative 1/2. Okay, so as I go through this expression and evaluate it, I have 4 minus negative 1/2 to the 8th power. Well, negative 1/2 to the 8th power should be 1 over 256. And then the bottom becomes minus the negatives plus a positive, so 1.5 or 3/2 on the bottom. Let's keep evaluating the numerator then. This would be 4 minus 1 over 64 divided by 3/2. That's going to be 4 minus 1/64 would be 3 and 63/64. So 3 and 63/64 as an improper fraction would be 255 over 64. And then I need to divide this, let me extend the page here, by 3/2. Well, dividing by a fraction is the same as multiplying by the reciprocal. So if I multiply by 2/3 here, I should get 510 divided by 64 times 3, 192. And then I'll go ahead and put that into my calculator and see if it does reduce. That'll get me my decimal, and I'll go to convert back to fraction form. And converting back to fraction form gave me 85 over 32. Okay, so the sum of this geometric series is going to be 85 over 32. So going through and using and applying the formula for these problems, make sure you choose the correct formula depending on the information that you have. Once you have the formula, again, it's just an algebraic computation to evaluate. Let's try example number 7. In 7, we have a sub 1 is 4, a sub n is 256, r is 4, and we want to find the sum of the geometric series. Okay, so s sub n is going to equal, now I'm given an a sub n, so I'll use the formula a sub 1 minus a sub n to the times r divided by 1 minus r. There's the formula I'm going to use. A sub 1, first term of the series is 4, minus a sub n, last term of the series, 256. R is that common ratio, which is 4, divided by 1 minus 4. So now 4 times 256. That should give me 1024, so 4 minus 1024 divided by negative 3. That'll be negative 1020 divided by negative 3. If I divide that out, I should get 340. Okay, so that's saying that the sum of the series where the beginning number is 4 and the ending number is 256, where the common ratio is 4, the sum of those numbers should be 340. Let's go through and just show you that this holds true. First number of the sequence we said was 4, and the r value is 4, so that's what I'm multiplying by each time. So the next one would be 16, and then 64, and then 256. Okay, and in this case, if I'm doing the sum of the series, I'm adding those together. So 4 plus 16 plus 64 plus 256 equals, and it did turn out to be 340. So my formula is working correctly as I go through these problems. Okay, let's try number 8. Problem number 8, I need to find a sub 1. I have s of 8, so that means the n value is also going to be 8. I know that. I know the r value. So let's use the a sub 1 formula. S sub n equals a sub 1 minus a sub 1 r to the n, all divided by 1 minus the r value. S sub n, 13120, equals a sub 1, which is what I'm trying to find, minus a sub 1, r to the 8th power. Well, the r value is 3 here, so we got 3 to the 8th power, divided by 1 minus the r value, which is 3. Okay. So first thing I'm going to do, I got negative 2 on the bottom, so let me multiply both sides by negative 2. And that would give me negative 26240 equals a sub 1 minus a sub 1, 3 to the 8th power is going to give me a 6561. So now what I got to do, since I have two a sub 1 terms, I could go through and write it like this. 1a sub 1 minus 6561a sub 1. If I combine like terms on the right-hand side, that should give me a negative 6560a sub 1. And dividing both sides by negative 6560, a sub 1, which is the first term of the sequence, should be 4. Find the first term of the geometric series. First term should be 4. So again, just more algebra to go through and do once you apply your formula. Okay, and the last one, let's use the summation notation with a geometric series this time. So let's go through and just find a few of the terms in my geometric series. This says the first value should have an x of 5. So first term in the geometric series would be plug in a 5, that'd be 10 minus 9, which is 1. So 3 to the first times 1/2. The first term is going to be 3/2. Okay. What's the next term going to be? Well, when x is 6, that'd be 12 minus 9, which is 3. 3 raised to the third power is 27, multiplied by 1/2, 27/2. And this is just going to continue on. And then the last term would be when x is 8. So 8 times 2 is 16, minus 9 would be 7. So 3 to the 7th power is going to give you 2187, and then I got to multiply by 1/2, so that would be divided by 2. So this should be enough information then to go through and apply one of the formulas. Let's use S sub n equals a sub 1 minus a sub n r over 1 minus r. I should be able to find a sub 1 and a sub n. A sub 1 is 3/2. A sub n would be the last number, 2187 divided by 2. R, what is the common ratio? What am I multiplying by each time in order to get the next number in the series? Well, it looks like I'm multiplying by 9. 9 times 3/2 would be 27/2, right? So the R value is 9, so I got 1 minus 9 on the bottom here. So this should give me 3/2 minus 2187 times 9 and then divide by 2. So that would give me 19683 divided by 2, and that whole numerator is then over negative 8. Okay, so if I simplify the numerator down, I can add 3/2 to negative 19,683 halves. So if I do that, that should give me a negative 19680 divided by 2 divided by negative 8. Let's go ahead and simplify the numerator now that I have an even number on top. 19680 divided by 2. It should give me a negative 9,840 on top divided by negative 8 on the bottom. And if I divide through by negative 8, I should come up with 1230. Okay. So there is the sum of the geometric series that we started with in this summation notation. So when doing geometric series, it's probably best to write out a few of the terms of your summation notation to get the first term, the R value, and also the last term. Okay? And that will conclude the notes for section 11.3 on geometric sequence and series.